In section 9.2, we're looking at the quadratic formula. Our objectives are to derive the quadratic formula, solve quadratic equations using the quadratic formula, and use the discriminant to determine the number and type of solutions. We can use the method of completing the square to solve any quadratic equation. However, completing the square can become tedious and time-consuming. In this section, we begin the general quadratic equation, ax squared plus bx plus c equals 0. Note that a, b, and c are complex numbers and a does not equal 0. By applying the method of completing the square to this general equation, we can develop a formula for finding the solution of any specific quadratic equation. The quadratic formula is a way to solve any type of quadratic equation, as long as the equation can be written in the form of ax squared plus bx plus c equals 0, and a does not equal 0. The solutions to this equation are given by x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now this is a big formula, and this is something you should definitely memorize. One way to memorize it is by using the quadratic formula song. You can sing the tune to the tune of row, row, row your boat, and this is how it goes. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I want you to practice that and write it down on a flashcard so that you have it handy and you have this formula memorized. So anytime you approach a quadratic equation, you can use this quadratic formula to solve it. Let's look at this example. Solve 6x squared minus 7x minus 3 equals 0. Always try factoring first. If factoring is difficult or impossible, use the quadratic equation. We're looking for the values of a, b, and c. Now the a, b, and c are the coefficients. The a is 6. The b is your coefficient of the x term, which is negative 7. And your c is the constant term, which is negative 3. The equation is written in standard form, so our coefficients, 6, negative 7, and negative 3, are used as the values of a, b, and c, respectively. Let's substitute what we know. X equals negative b. Well, if b is already a negative 7, then the opposite of b would be negative 7 or positive 7, which we'll simplify in just a bit. Plus or minus the square root of b squared. Well, b is negative 7. You want to square that entire quantity. Be careful with the signs here. Minus 4ac, where a is 6 and c is negative 3. All divided by 2a, or 2 times 6. Now let's simplify each part. Be careful with the order of operations here. The negative 7, that's going to be a positive 7, plus or minus the square root of, do the exponents first. Negative 7 squared is a positive 49, minus 4 times a times c. Well, 4 times a times c is 4 times 6 times negative 3 is negative 72, and that minus a negative is going to be a plus, all over 2 times 6, which is 12. Let's continue to simplify, and we get x equals 7 plus or minus the square root of 49 plus 72 is 121, all divided by 12. The square root of 121, that works out nicely to be 7 plus or minus 11. Square root of 121 is 11, all divided by 12. Now we can break this up into two problems, one with a plus, one with a minus, to get our two answers, where x equals 7 plus 11, all divided by 12, which is 18 over 12, which can be reduced to 3/2, or even as a decimal 1.5. When you use the minus sign, we get x equals 7 minus 11 divided by 12, which is negative 4 over 12, which is simplified to negative 1/3. So here we have our two solutions to the quadratic equation by applying the quadratic formula. As always, you should check your work. Check each of those in the original equation. When you check x equals 1.5 or 3 over 2. You can plug that into your formula, your original equation, 6 times 3 over 2 squared minus 7 times 3 over 2 minus 3. You can use a calculator to simplify that, and you will find that it does equal 0. So x equals 3/2 is a solution to the quadratic equation. We can also check x equals negative 1/3 by plugging in negative 1/3 where you see an x in the original equation. Again, you can go through, simplify that, and you will find that that does equal 0 as well. So both of our solutions do work. The check step verifies they're both solutions to the original equation. Let's solve this equation. First, we want to write it in standard form. Again, standard form before we apply the quadratic formula, the equation must be written in the form of ax squared plus bx plus c equals 0. If it's not in this form, don't use the quadratic formula yet. Notice that we have a 4 on the right side, but we want standard form to have a 0 on the right side. So we must first subtract 4 from both sides of this equation. Then our equation becomes 2x squared plus 3x minus 4 equals 0. Now that it's in standard form, you can check to find the a, the b, and the c. So our a is 2, the coefficient of the x squared term, the b is positive 3, and the c is negative 4. Our equation is in standard form, so you can pick out those values of a, b, and c. Now we can apply the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go through step by step. Negative b, that's negative 3, plus or minus the square root of b squared, that's 3 squared minus 4ac, all divided by 2a, or 2 times 2. Let's simplify each part of this. In the numerator, we get negative 3 plus or minus, and I like to do the powers first. 3 squared is 9 minus 4ac. That's negative 4 times 2 times negative 4, which will give us a positive 32, all divided by 4. Let's continue to simplify what's under the radical. We have negative 3 plus or minus. Under the radical, we have 9 plus 32. 9 plus 32 is 41, all divided by 4. Now, the square root of 41 cannot be simplified. There are no perfect square factors of 41. So we can write our two answers as x equals negative 3 plus square root of 41 over 4, and x equals negative 3 minus the square root of 41 over 4. Those are our two solutions. We do want to check to make sure those are solutions to the original equation. So take your time to check those on your own, and you'll see those are correct solutions to the equation. All right, let's take a look at this one. We want to solve x squared minus 3x plus 3 equals 0. The equation is already written in standard form, so we can determine our values for a, b, and c. A is the coefficient of the x squared term. There's no number in front of the x squared term, so we know that that is a 1. A equals 1. B is the coefficient of the x term, which is negative 3, and c is the constant term, positive 3. We can plug this into the quadratic formula where x equals negative b, so it's the opposite of negative 3 plus or minus the square root of b squared. I like to put the b squared in parentheses because you want to make sure you square the entire quantity b, not just the 3. B squared minus 4ac, where a is 1 and c is 3, all divided by 2a, or 2 times 1. We want to simplify each step here. The opposite of negative 3 is positive 3 plus or minus the square root of negative 3 quantity squared is 9, and minus 4ac, 4 times 1 times 3 is minus 12, all divided by 2a, or 2 times 1. Now let's continue to simplify. We have 3 plus or minus the square root of 9 minus 12. 9 minus 12 is negative 3. So it's going to be the square root of a negative 3, all divided by 2. Now the fact that we have the square root of a negative should be a flag here, that you have an imaginary solution. So we can write this as x equals 3 plus or minus I square root of 3 over 2. This can also be written as x equals 3 over 2 plus or minus I square root of 3 over 2. So you have the real part and the imaginary part of the complex solutions. Using the discriminant to predict the number and type of solutions, the solutions of the quadratic equation ax squared plus bx plus c equals 0 are given by the quadratic formula. Now the part that is underneath the square root, this part right here, is called the discriminant. The discriminant tells you what type of solutions you're going to have and how many. If a, b, and c are integers, the type of solutions of a quadratic equation, that is, they're either going to be rational, meaning they can be written as fractions, irrational, or even non-real complex solutions, is determined by the expression under the radical symbol b squared minus 4ac. This expression is called the discriminant because it distinguishes among the three types of solutions. What information the discriminant predicts? Discriminant. The discriminant of ax squared plus bx plus c equals 0, that's the quadratic equation in standard form, is b squared minus 4ac. If a, b, and c are integers, then the number and type of solutions are determined as follows. If the discriminant is positive, you can take the square root of a positive number. And if it's the square of an integer, that means it's a perfect square. Then when you take the square root of a perfect square, you get a nice whole number. So the types of solutions you're going to have is going to be two rational solutions, two answers that can be written as fractions. If the discriminant is positive, but not the square of an integer, it's not a perfect square, then your radical will not be able to be simplified out. So you will have two solutions, but we consider them to be irrational solutions. They can't be written as simple fractions. If the discriminant is 0, you're taking the square root of 0, which is 0. Now recall that the quadratic formula is written in the form of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the discriminant part here is what's underneath the square root sign. If that is 0, then in the numerator it's negative b plus or minus 0. So whether you add 0 or subtract 0, you're not going to get a different answer. So you will end up with just one rational solution because you're adding or subtracting 0. Now, if the part that's under the square root is negative, if this part here ends up being negative, then you're taking the square root of a negative number, and that's imaginary. So the type of solutions you're going to have are complex solutions where you have a plus or minus bi. You have that imaginary part. So for these examples, we're looking at not what the solutions are, but what type of solutions will be found just by looking at the value of the discriminant. The discriminant, again, is b squared minus 4ac. The equation 3x squared plus 2x plus 4 equals 0 is a quadratic equation that's written in standard form. A is equal to 3, b is equal to 2, and c is equal to 4. So b squared minus 4ac can be found as 2 squared minus 4 times 3 times 4. When you simplify this, you have 4 minus 4 times 3 is 12 times 4 is 48. 4 minus 48, we end up with a negative 48. So in the quadratic formula, the square root of b squared minus 4ac, you're going to end up with, again, recall the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the fact that this b squared is the b squared minus 4ac is negative, then we know that we're going to have two non-real complex solutions to the quadratic equation. For the example on the right, the equation is written in standard form where a is equal to 1, b is equal to 2, and c is equal to 1. By applying the discriminant, by calculating that, we get 2 squared minus 4 times 1 times 1, which is equal to 4 minus 4, which is equal to 0. Now, since the discriminant is 0, when you are substituting into this quadratic formula, and if this entire quantity is 0, you're adding and subtracting the square root of 0. You're adding and subtracting 0. So you will have only one real solution. In fact, it's going to be one rational solution. So it gives you an idea of how many solutions you're going to have, the type of solution, whether they're real solutions, rational, irrational, or complex solutions. Let's find the discriminant of 3x squared plus 5x minus 2 equals 0. Because the equation is written in standard form, we can say that our a is equal to 3, our b is equal to 5, and c is equal to negative 2. When we substitute that into the discriminant formula, b squared minus 4ac, we get 5 squared minus 4 times 3 times negative 2. This simplifies to 25 minus 4 times 3 times negative 2, which is a negative 24. So that's going to be plus 24. And 25 plus 24 is 49. Now that's a perfect square. Again, recall that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If this number right here is a perfect square, then you're adding and subtracting an integer. So you're going to end up with two rational solutions. So two solutions that you can write as reduced fractions. On the right side, x squared plus 7x minus 15. Because the equation is written in standard form, we can identify that a is equal to 1, b is equal to 7, and c is equal to negative 15. Using the discriminant formula, b squared minus 4ac, 7 squared minus 4 times 1 times negative 15 is going to be 49 plus 60, which is 109. Now 109 is not a perfect square, but it is going to be a real number when you take the square root of it. It just won't be a rational solution. So we say we have two irrational solutions because the discriminant is positive, but it's not a perfect square. All right, so that wraps up Chapter 9, Section 2. Work on the assignments for Chapter 9 and review all the previous chapters and be prepared to take your final exam.